right, hello all. Remember, we are broadcasting not from Henslick today. We will be back in Henslick starting Wednesday, but for today, I'm broadcasting from home, and today we're going to be starting on our next topic, which is strings. So we'll just go ahead and start getting right into it here. Let me go ahead and transition over. You've already worked with strings in C before. Just double check, mic check here. All right, good. So you've already worked with strings before in C by using the double quotes. Anytime you use the double quotes and put in a sequence of characters, that is a string. In C, strings are nothing more than ordered sequences of ASCII characters. ASCII characters being from the ASCII text table. Now, in a lot of programming languages, strings can be extended to Unicode characters. For example, CJK fonts, Chinese, Japanese, Korean fonts, or emojis or things like that. Extended for other languages beside English. Except in C, we're only really dealing with ASCII character sets. If you want to deal with Unicode, you basically have to bring in a library and do some other things that we're not going to get into here. All right. In C, strings are simply null terminated arrays of character elements. Right. In other words, char elements. Right. And you're already familiar with single char elements because you've worked with them before. Single character elements, you denote with single quotes. Now, what does null terminated mean? That's going to be that's the subtle difference. But it's a subtle difference, but it's a huge difference between, say, arrays of integers versus arrays of, now that we're dealing with them, characters or strings. I do remind you that we are on Piazza for live Q&A, as well as the live stream YouTube chat if you want to crosstalk. So what does null terminated mean? Well, here's the big difference. If you are dealing with an array of integers, say that there are 5 integers in that array, that means that there are only 5 elements in the array. 4 bytes per integer means that you've got 20 bytes in that array. 4 times 5, 20 bytes. Now, in a character array, in a string array, the size is less of an issue because you can store strings that are smaller than your capacity. So, for example, if I have an array of 20 characters, but I only store 5 characters in the first 5 places, and then I null terminate it and say that that's the end of the string, then that string is only of length 5, even though it has a capacity for more. Not only that, but with integer arrays, you have to keep track that there are only 5 integers in there. With a string array, you do this differently. You null terminate it. You put the special character at the end that says that this is the end of the string. That my name, CHRIS. Then a null terminating character that indicates the end of that string. Okay? In addition, most libraries, or most languages, and C is no exception in here, most languages provide a robust library to process strings. Right? C provides the include string.h library. Right? So you can include this like you would any other standard library. The string library has a few dozen different functions that will help you in operating on strings. Because the way that you operate on strings is very different than the way that you operate, say, on an array of integers. Right? And again, to reiterate what I was talking about before, in C, all strings must be terminated with the null terminating character. Right? The null terminating character is this special character that is /0. It has an ASCII text value of 0. It is not 0 itself. If you look at the ASCII text table and you see that capital A has the value 65, lowercase a has the value, I believe, 97. Right? If you look at the very beginning of the table, there's a special character there that doesn't print anything. It's called the null terminating character. The null terminating character is the /0 character. Right? It is not the same thing as 0. Right? it is not the same thing as the pointer null, right? So we're using the same terminology here, null terminating character, but is not the same thing as the null pointer, all right? So in other words, we have yet another definition of nothing. 0 is nothing, but it's a numerical nothing. Void is a nothing that you use with respect to functions to say that this function doesn't return anything. It returns nothing. It's a void function. Null is a pointer nothing. It points to the null pointer location. 0 is a brand new type of nothing. Do not conflate it with all the nothings that you've seen so far, okay? It's a brand new nothing, right? It has ASCII, a value of 0 in the ASCII text table, but it itself is not 0. In fact, if you look at the ASCII text table, the character 0, right? It has a completely different value. It's much later along with the numbers. We can look it up later if you really want to, but I would go ahead and encourage you to do that on your own. If you don't null terminate your strings, bad things will happen. If you don't null terminate your strings, many of the string library functions will not operate correctly. All right. In fact, much of your code won't operate correctly. Right. So let's go ahead and just jump right into it and take a look at some examples here, getting started with strings in C. All right. In C, strings again are arrays of char elements. So you can use the same syntax that we've been using up to this point in order to declare a string, right? You can declare a string similar to how you declared arrays of integers or doubles, etc., right? So let's just go ahead and get into code mode here. And let's go ahead and create a string to hold my name. Char name. How big do I need to hold? How big of a string do I need? Well, my name, if I want my short name, CHRIS, then that's only 5. But if I want my full name, it's Christopher, I don't know how many there are, and I'll just overestimate this here. So let's go ahead and create a string of length 30. I shouldn't say the length 30. This is capacity 30, right? And I can immediately set it equal to my name, Christopher, my full name, all right? In fact, let's go ahead and make an intentional mistake here. And I'll go ahead and put it as a lowercase c to begin with. All right. Now, what does that look like? I've created an array of size 30. And I've only set the first few characters in that. What about what does the rest of the characters look like? And so I'm going to bring up the C tutor here, where I've basically created a name, but I've used the capital C here, and so it's okay for the visualization. But let's go ahead and walk through this code where we initialize it to Christopher, right? After that initialization, you'll see that Christopher, CHRISTOPHER, is now in this array, at least the first 11 characters there. What's after that? There's that null terminating character, that \0. But what about the rest of the array? Well, the rest of the array has been filled with null terminating characters. Now, that's going to be the compiler. That's going to be your particular system. It could be filled. The rest of it could be filled with garbage, for all you know. So you don't make any assumptions about what's been loaded into the rest of that string. All right. But you can see here that we've got a capacity to hold up to 30 characters -1. Why -1? Because if I filled this all the way up to index 28, in other words, I put 29 characters in there, I would still need room for that one null terminating character at the end. If I don't have room for that null terminating character at the end, then bad things will happen. It ends up being a non-terminated string. And so if you go to, say, print it out without that null terminator, then how does it know where to stop? Right? So, for example, let's go ahead and take a look at REPL here. Right? Instead of making it 30, I will go ahead and say, I'll let the compiler just, well, remember it was 11 characters, right? 5, 6, 7, 8, 9, 10, 11. So we'll go ahead and make it only a capacity of 11. Now, remember, we've got 11 characters here. Technically, to hold my name, my full name, we would need 12 characters for that null terminating character there. Right? Let's go ahead and find out what happens. Probably the compiler will catch this and say that we can't do something like this. Okay, well, it's not doing anything, sorry. Let's actually go ahead and print it out. Printf, %s, and the line. We'll go ahead and print out my name here and see what happens. All right, REPL seems to be misbehaving today, so we'll go ahead and forget about it and go over to the CS50 IDE here instead. All right, we'll get the same effect. It's just that I'm going to have to compile now from now on. All right, so gcc demo.c, and we'll run it. All right, Christopher. Now this prints out because we got lucky. It encountered some null terminating character eventually. What if it doesn't encounter a null terminating character? What if we make this even smaller? Right, 4. Now we're potentially overwriting memory here that probably belongs to us. In fact, there's going to be a warning here that this is not that we don't have enough room for this. In fact, I could probably go down to 10 here, and I would still get the warning. All right, yep, and let's go ahead and run it and see what happens. Okay, so it looks like it took care of it for me. There's no guarantee on that, right? This is just the compiler being smart about it and saying, okay, I'm going to save you from yourself a little bit here, because this is not a character array of size 10 is not enough to hold my name with 11 characters plus the null terminating character, right? But I can go ahead and assign myself my name here. This 30 is more than enough to hold that string. If I wanted to, of course, you could assign to an array of an exact size by, of course, doing the same thing, but then going around and counting, okay, well, there are 11 characters plus the null terminating characters, so 12, or you could let the compiler do your work for you. Remember that we had, this is called elision, that the compiler is smart enough to go through and say, oh, count up the number of characters plus the null terminating character, I can take care of that for you. Just like it did with the primes example that we've looked at before, where we declared an array of integers to hold the first 10 or 7 or 8 primes. It was able to go through that list, that comma delimited list, and find out how many things we actually wanted to store. Right? So we'll go ahead. I can assign it and elide out the size of the character array, and it'll take care of all those details for us. In addition, strings in C are mutable. Right? In other words, the contents of a string can be changed. Right? For example, let's go back into code mode here. I misspelled or I didn't make a capital on my first character, so let's go ahead and take care of that now. Let's change the first character of that array into a capital C instead. So name, where is that first character located? Well, it's an array, so it uses 0 indexing. We start at 0, then the second character is at 1, 2, 3, etc. And so if I want to access the first character, then of course I can just set it equal to capital C. Beginner mistake here. If you do double quotes, that is a string. The string C with the null terminating character after it. That's actually 2 characters, and I can't assign 2 characters to 1 slot. So this is not going to work. If I have a single character, I need to use single quotes. And this is the correct way of doing it. All right. Then you can print it, of course. Remember, we've already covered this before with printf. You can use the %s placeholder in a printf to print strings. Right? So if I want to print my name again, printf %s, or hello, I'll greet myself. Right, and go to the end of the line here, name. Right, just like I was doing in the CS50 IDE here. Let me give myself some more room so that this always pops up, at least to the halfway point. All right. So again, I'll go ahead and take this over there and show you that it works. That we'll go ahead and change this to lowercase c, print it out, and then we'll go ahead and change my first character into a capital C, and then I'll print it out again here. Okay? And we'll see that it prints lowercase Christopher and then an uppercase Christopher because we have changed the contents of the string. Of course, remember we can use keywords like const to make it immutable. In other words, that it can't be changed. Just like if we pass an integer array to a function that we don't plan on changing the contents of, we can declare that as a const array. We can do the same thing with strings. All right? So remember that when we start working with strings and functions. All right? If you don't intend to change the string, then you may want to make it into a const. Right? You can also truncate a string by setting any of its characters to the null terminating character. So, for example, now I just want my shortened name. I just want Chris, C-H-R-I-S. Well, that would be 0, 1, 2, 3, 4. If I want to cut it out after 5, then all I would need to do is set the 6th character, in other words, the character at index 5, to that null terminating character. So, name sub 5 is equal to that null terminating character. Now, you might be wondering, well, wait a second, that's actually 2 characters, right? This backslash and 0. Well, the backslash doesn't count because the backslash is an escape character sequence that we're not going to print. If I didn't have that, of course, it would say, well, then now that's the character 0, not the special null terminating value. But by putting backslash, then it's going to be 0. Let's go ahead and see that again in action over here in the CS50 IDE. Name of 5 is going to be equal to, let's go ahead and make that mistake of setting it equal to the character 0 first and printing it out. And you'll see that when I do this, it's going to be Chris 0 Ofer, right? So it's going to look weird, right? That's the character 0. That's not the null terminating character 0. Null terminating character, excuse me. When I do it like this and compile, now you see that it has been actually cut. Now, the contents of the string have not changed. In fact, if I take this over and visualize this, it might take a while to visualize this, so I'll go ahead and move on and we'll come back to it if it takes too long. But basically, the capacity of the array is still there, right? There, excellent. So if I go and I initialize it, of course, Christopher, it automatically put that null terminating character in there for me, it being the compiler, right? So I didn't have to put the null terminating character over here in the string declaration because it takes care of it for you at initialization. It prints it out, right? Hello, Christopher. I changed the first character to a capital C, and you can see there that it's been changed. I print it out again. Right? Now I changed the 6th character, this character right here, index 5, into the null terminating character. You can see that the rest of the string is unaffected. Right? But basically, I've truncated the string. I have not changed the other contents of the array. I've not changed the size of the array because you can't even do that. That would require, in this case, that would require deleting or manipulating memory in the stack. That's going to be a stack smasher to free that up. If it were a dynamically allocated string, then of course I would need to free it up. There's no way that you can shrink or grow, or you can grow, but there's no way that we've looked at so far that you can expand the memory of a dynamically allocated array, right? You can call realloc, but we don't cover that in this course. Okay. All right. So you can truncate a string by doing something like that. Well, what if I wanted to change the entire contents of a string, right? If I wanted to change it so that it was a completely different name, Joe or something like that, I would have to go character by character by character. I'd have to say name of 0 is equal to J. Name of 1 is equal to lowercase o. Name of 2 is equal to e. And if I wanted to end it there, I have to take care of the null terminating character now because I've already created the string. The compiler will only take care of the null terminating character when you create a string or in other very special circumstances. So you need to take care of it yourself in general. And when I put that in there, now I've changed the name into Joe. I haven't changed the rest of the contents of the string, but I've changed the name. That seems like a lot of work, right? 4 lines of code to change it character by character by character by character. But we don't want, so we don't want to do that, right? So string assignments. Right? So you cannot use the assignment operator here. You cannot use the assignment operator, that is the equal sign, to assign a new value to a string. Right? It might look like it's going to work, but it's actually not going to work. What you're going to end up doing is you're going to end up having a memory leak. All right, and in a lot of cases, it won't even let you do it. And in fact, let me try it over here. It probably will let me do it here, but hopefully not without a warning. Name is equal to Joe. Let me go ahead and try this and see what happens. Save it. Yep, error. Assignment to an expression with an array type. You can't do this. Right? You can't do this because name has already been created to be an array. This is a string. You can only assign individual elements in an array: the first character, the second character, the third character. So the way that you do this is by going to the string library. There's a function in the string library that'll let you do this already. Let's see. There we go. There is a nice string copy function in the standard string library, right? And its name is strcpy. In fact, I'm going to go ahead and copy the entire signature of this string. There we go. Char, and it does have a return type here. Don't worry about the return type. We won't be using it. But there's a destination string and a source string. The basic idea here is that it copies the contents of the source string into the destination string. So strcpy, and it's short for string copy. Why are these again truncated a little bit? Why isn't it string copy or copy string or something like that? Again, because 40 years ago, it actually, or 30, 40 years ago, whatever it was, it actually mattered that if you could get away with a few characters being cut out here and there, it actually mattered because you measured your disk space in kilobytes. So if you can save a few bytes here and there, you did it, right? Of course, we're still living with that today, even though we're not paying by the byte anymore. A space is a character. In fact, I forget what it is in the ASCII text table, but it is a character, and it would count if you spaced things out. So if I had Christopher Burke here instead, that character right there counts as a character, right? And when we get into string defining the length of the string, that character will count. The null terminating character won't count, but all spaces count. In fact, a tab counts. An end-line character counts. Those are all single characters, right? They're all special characters that need to be escaped, but they're still characters. So back to strcpy, it copies the contents of the source string into the destination string, right? But there are a couple of assumptions here. It assumes that source is properly null terminated. If not, then it could be bad. Then there could be garbage. Basically what it does is it starts at the beginning of the string and it copies character for character for character until it gets to the null terminating character, at which point it copies the null terminating character and takes care of that for you, but then it stops. If it never sees that null terminating character, it's just going to keep going. It's going to keep going until it sees a byte that is 0, which it'll interpret as the null terminating character, or it starts to get into memory that doesn't belong to you, in which case, yeah, it'll die, right? It'll segfault out. So it assumes that the source is already a properly null terminated string. Right? If not, then it breaks. It also assumes that the destination is big enough to hold the contents of source. Right? If it's not, then it'll just keep writing memory. Right? If not, then, again, you'll get maybe get a segmentation fault. Right? There was one other thing I was going to say, but I forget it now. But one thing I do want to draw your attention to, notice the source is declared as const, i.e. it is read only. Right? So the source is const. We're not going to change it, and we can't change it because it's const. And we're going to copy it into destination, which is not const, because we will be making changes to that, that character array. So let's go ahead and take a look at an example here. What I'm going to do is I'm going to combine a couple of things. First of all, what I was just doing was declaring a bunch of static strings, strings that were created on the stack, just like static arrays. For the most part, you're going to want to be dealing with dynamic strings. So let's go ahead and create a dynamic string big enough to hold my name, Christopher. There we go. All right, so I'm going to create a character star, char star, and I'll call it name, just like I was doing before. But it's not declared with the square brackets anymore because this is a dynamically allocated string. We're going to be dynamically allocating this by calling malloc, just like we did with integer arrays. But it's a character array, so when we typecast it, the returned pointer, it's now a char star instead of an int star or a double star. Now, how many bytes do you need? In C, characters are almost universally 1 byte. So you could get away with, in this case, what do we need? 11 characters or something like that, right? You could get away with doing something like this. It's not great practice. Even though it's almost guaranteed to be only 1 byte, you still should be using the size of macro here, the size of char. Right? Now, granted, that's always universally going to be just 1, but still, if you want to make your code future-proof, if they ever change it and add native Unicode support and characters suddenly become Unicode characters, then you'll be glad that you did this. And also, it's just consistent with everything that we've done up to this point. You might as well just continue doing it like this. Now, how many characters do you want? I seem to remember we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I need size 11. Nope. Remember, what are we forgetting at the end? We need 11 characters plus 1 for that null terminating character. So I'll put in 12. Right? Now let's print it out and see what it is. We haven't initialized it to anything yet, right? We've just declared this memory over there. In fact, it's not even guaranteed to be null terminated. So what I'm about to do is actually undefined behavior, technically. Let me greet myself again. Hello. Me. All right. Let's run it. Hello, and then it's not printing anything out because it's an uninitialized string. It probably filled this up with a bunch of null terminating bytes. So it's not actually, it's printing this a space here, and then null. When you print null, the null terminating character, it doesn't print anything. It doesn't even print a space. The null terminating character is not a space character. It is an unprintable control character. So great, it filled it up for us. I, of course, could go ahead and manually do this myself. There's a capital C, name sub 1 is equal to a lowercase h, and it gets kind of tedious. I don't want to do it that way. Instead, what I want to do is I want to copy an entire static string into my dynamically allocated array. To do that, I'm going to go ahead and call strcpy. Remember that that is in the string library, string.h, so you have to bring that in. I'm going to copy into name the character sequence Christopher. Right? Now remember, this is the destination. So it goes destination, then source. Why? Well, it's just like int x is equal to 10, right? You're taking the value on the right-hand side and putting it into the variable on the left-hand side. So you're taking it and putting it like that. The same pattern follows with string copy. It takes the right argument, and puts it into the left variable, right? So even though you can't use an equal sign, you can't use an assignment operator, it still follows the same pattern. Now when I copy this in and run it, now it says my name, right? Hello, Christopher. I didn't put a null terminating character here. In fact, it would kind of be wrong and weird to do that, because what's going to end up happening is it's going to try to copy Christopher and a null terminating character, and it's going to want to put maybe it's going to want to put another null terminating byte in there, and that's not what you want. You generally let strcpy take care of it for you. It's going to take care of the null, as long as the source is null terminated. It will take care of the destination's null termination. Okay. All right. What if it's not big enough? What if I try to put in my full name, Christopher Michael James? Oops. James Burke. All right, I'm not a junior or anything like that. Let's go ahead and find out. All right. This would be like trying to copy over, yeah, Christopher Michael J. Right? It dies out here. Why? Because, well, I've corrupted memory. It's undefined behavior. I've tried to fit this huge giant string into an array that can only hold at most 11 characters. It can hold 12 bytes, but it can only hold 11 valid characters because it needs that null terminating character at the end. So this is undefined behavior. It's printing out garbage. I don't know. I don't even know if it's determinate. Yeah, okay. It's going to end up doing the same thing over and over again. But it's certainly not correct. All right. Now, if I want to, I can go ahead and overestimate and say, okay, well, my name, I don't know how many characters are in there. I don't want to count those up. So I'll just go ahead and overestimate this here and create an array of size 100 that can hold 99 characters, at most 99 characters. And this should work. Now, of course, at the end, I am wasting a bunch of bytes. However, 99 bytes minus however many characters are actually in my name sequence here. But that's not that big of a deal, especially if you are going to be dynamically allocating a string temporarily, so that is big enough so that you can work with it. And then once you've got the string, once you process the string and you've got the result. Then you can create a new string that is exactly the size that you need, copy everything over, and then destroy this temporary string workspace that you are working with, which is a common kind of pattern. Right? So there's also an alternative strcpy. There is a byte limited version, which is called strncpy. The N stands for well, it's just an integer that basically it copies at most n characters over to the destination string. Right? Let me go ahead and get the, where is strncpy? Okay, I'm gonna have to command strncpy. Let's look that up. There we go. There's the and here they've abbreviated everything into dest for destination and src for source. And I'll copy that over into the notes, but of course you can always look up the man pages on it. There it is. It copies source into destination, but only at most n characters, right? Over to the destination string, right? If the null terminating character occurs within the first n characters, it takes care of it for you, right? In other words, it copies the null terminator. Right? If not, if it is not within the first n characters, it will not copy the null terminator, and you need to take care of it. All right. So before we take a look at that example, let's go ahead and take some questions here. Do you always have to use a number to specify the size of a string when using malloc? Well, you have to use something because malloc requires that you tell it how many bytes that you want. Now, if it's, the examples that I was using here were hard-coded numbers. In general, you don't do that. If you're trying to copy one string to another string, then you would need to find the length of that first string, which we'll talk about here in a moment. Okay? So let's go ahead and take a look at the alternative here. Right? I don't want to copy the first, copy everything. I'll only copy, in fact, let me set it up differently here. No, this is good enough. I only want to copy the first 1, 2, 3, 4, 5 characters into my name, right? So I'll go ahead and call strncpy and say that I only want the first 5 characters, okay? But before I do that, let's go ahead and fill out this name with a bunch of star characters. So what I mean by that is, because I want to demonstrate this visually, for int I equals 0, I is less than, say, 50. Well, I'll fill out the first 50 characters in this name with a bunch of star characters. So name sub I is equal to the star character. Right? And, and then at the very end here, name sub 50, I'll set that equal to the null terminating character so that it is a properly null terminated string, and I'll print it out. There we go. So we'll see, 50 stars, and then at the end of the line, and then when I copy just my first 5 characters over here, let's see what happens. Oops, that's not what I wanted. Run it. There we go. Hi, Chris. We only copied the first 5 characters, and we didn't see, or strncpy did not see the null terminating character within the first 5 characters. So it ended up not copying that null terminator over, meaning that all the stars that we put up before are going to be retained, right? We need to handle that ourselves. After we copy those first 5 characters, then we need to make sure that it's null terminated. So name sub 5 is equal to the null terminated character. And when we do this, now all those stars will be gone. Right? I had to fill them with stars because the compiler was filling them with null bytes, and so they would not end up getting printed. I had to do this for visualization purposes. Okay. All right. Well, as the question alluded to online, what happens when we just have some string that we want to copy and we don't know how big of a string this is? Well, we could go through and count up the number of characters, right? Just a while loop, right? Let's go ahead and let's go ahead and do that. How big is this string now that I've null terminated it? Right? So int count is equal to 0. Right? While the current character in name is not equal to the null terminating character, then we'll go ahead and increment count. Right? And at the end, printf, and also increment I here. Let's just take care of I right away, our index variable. And I'll start it at 0. Right? We could probably reuse the count variable right there, but I don't want to. The string %s is blank characters long. And the line, and the string that we're trying to count is name, and the count would be, of course, count. There we go. So chris is going to, of course, be 5 characters long. Right? Now, this is such a common, and frequent operation of given a string, how long is a string? Then now, note here that the actual array, we remember that's 100 bytes long, right? It has a capacity to hold up to 99 characters, allowing for that null terminating character. But the actual string that we've stored in the program up to this point is only chris, my name, right? 5 characters long. Once we get up to that null terminating character, then that's the end of the count. That's how long, that's the length of the string. And this is such a common operation that it's already built into the string library, right? So the length of strings, or string length. The length of a string is the number of characters in it, not counting the null terminating character. Right? To compute the length of a given string, you can use the string library's strlen function, right? Which essentially just returns an integer It goes through, counts up the number of characters in it, not including the null terminating string, and returns the result, right? So again, let's go ahead and look at an example. Instead of doing this, I can go ahead and get rid of all this code and replace it with an strlen of name call, right? And again, string length is shortened for string, strlen is shortened for string length. And it will go through and count them up, and I should get the same exact result here, that it's still going to be 5 characters long. But I don't have to roll my own function to do this, right? strlen. Now, what if it's not null terminated? Well, strlen will just keep counting, count, until it finds a null terminating character. And then at that point, of course, it'll stop and return the result, which will not be the correct result, or it'll just keep going on until it reaches memory that doesn't belong to it, resulting in a segmentation fault. Okay? All right. So, strlen, the string length function. Right? At this point, we can do a small little exercise. Well, hopefully it's just me. I've gone ahead and closed my back stream here, but hopefully OBS is saying that we're still pretty good on pushing data out. Hopefully it's fine. I've never encountered this problem before at work, of course. This is why I broadcast from Henslick. They've got a much better internet connection than I do here at home. So hopefully it's still working. If not, let me know. But in any case, we also always have those backups, pre-prepared videos as well. Right? So at this point, what I wanted to do is let's do a little bit of an exercise. Right? Remember that a shallow copy is simply a reference copy. Right? In other words, you have 2 pointers that are pointing to the same thing. So changes to one element, all right, affect both. A deep copy is where you copy the contents of, say, a string into a completely new string, so that changes to one do not affect the other. All right? So we have enough here to go ahead and create a function that will do this for us. strcpy, that will only copy content. So it assumes that this string is null terminated. It assumes that this string is big enough to hold the first string. It just simply copies over the amount. This is memory has already been set up for you. So as an exercise here, let's go ahead and create a deep string copy function. Right? So char star deep string copy. In other words, I'm going to return a completely new string here, right, that is equal in size to the old string with those contents copied over. So in other words, I need to take that old string. And I'm not going to be making changes to that old string, so I'll go ahead and make it into a const char star source. I'll call it src, right? So short for source, right? What this is going to do, again, if I want to document this, is it's going to copy or creates a new deep copy of the given string and returns the new string, which has the contents of the old string. Now, you might be wondering, wait, when we worked with arrays, we passed in the array. We also passed in the size of the array because we had to do our own bookkeeping. In this case, we don't have to do our own bookkeeping if we make sure to always null terminate our strings. We're going to be able to use strlen to determine how big of a string do you need to set up by looking at the old string and counting up the number of characters until you get to that null terminating character. Then we'll be able to use malloc to create a new copy that is exactly the size that we want. We'll be able to use strcpy to copy over that old string into the new string and then return the new string. Really, it's only a 4-liner, right? So what I want to do here is create a new copy, char copy is equal to a call to malloc, right? Size of char. Now, how many do you need, right? Well, I need as many as the old string, so I will go ahead and say strlen of src. Now, or src, sorry, there we go. All right. Now, look at that really carefully, really quick, and tell me, is that correct? And hopefully you're saying that the answer is no. If that old string is chras, that's 5. strlen does not include the null terminating character. We do, though. We need to create enough memory to hold chras and the null terminating character. Here is a common erroneous way of doing it. This will end up looking like it works. In fact, it will end up working because of the assumption that size of char is always going to be 1. But mathematically, that doesn't make any sense. What I need is as many bytes as a character takes times 1. So make sure that you're putting parentheses around this. Right? Once I've created enough memory to hold it, of course, you can do null pointer checks and everywhere here. For example, if the string is null, then the only thing I can return here, because it's a null pointer being returned, is return null. Right? You could check to see, was the call to malloc successful by checking that copy is not null and then returning null or crashing or something like that. I'm not going to go that far. What else could happen here? Could you have a string of a negative size? No, because of the way that we're using strlen here. It will only ever return something. You can have a 0 length string, just a string with a null terminator in it, and that's it. The length of that string is 0. It's not 1 because of the null terminating character. It is of length 0. You can actually get that by just showing, double quote with nothing in between. Okay. Is there an array length function similar to strlen? No. Period. Absolutely not. That is why you need to do your own bookkeeping. It'd be very nice if there were, but in C there is not. In other programming languages like Java, you do have this dot length. In Python or in PHP or JavaScript, you have functions that you can call that count up the number of the things in the array. But in C, no, you need to do your own bookkeeping. Strings are different in that you have the assumption that it's null terminated, and so you can exploit that assumption to count the number of characters in the array. It still doesn't tell you how big of an array that is because of the example down here. That the array is of size 100. It is of capacity 100. But unless we store this into a variable, there is no way to retrieve this 100 back out from this original call to malloc. Okay, so we've got our copy here, strcpy. I'll just go ahead and copy the source, and then I'll return the copy. There we go. And that's all there is to it. I'm simply using the string length to get the original string length plus 1 for the null terminating character, using strcpy to take care of the null terminating character for me, and returning the copy. So let's go ahead and actually let's do it like this. I will go ahead and copy my entire name into name, and then I will, in fact, let me go ahead and go with lowercase c here. And what I'll do is I'll create a deep copy of my name, corrected name, and it's going to be a char star. And I will go ahead and, or a copy of my name, and call deep copy of my name, right? And then we can print both of these things out. Printf original is equal to %s and the line and name, and then the same thing, corrected or copy, whatever you want to call it, and the corrected name. I'm calling it corrected name because what I want to do is I want to show you that changes now to 1 do not affect the other. So if I correct my name and go with a capital C on the corrected version, then that won't affect the original name string of 0 is equal to capital C. There we go. All right, no other questions so far. And again, I had to close the YouTube live stream because the quality was degrading. So I'm no longer looking at the live stream chat. All right? Talk amongst yourselves if you want, but otherwise I won't be able to answer questions from it. All right? There. So there's the original copy. There's the deep copy. And changes to the deep copy do not affect the original copy here. All right? Great. Good first exercise there. All right. What else can we do with just what we've covered so far? Let's see. Deep copy. Concatenation. Let's talk about concatenation, and then we'll end it for the day. So, concatenation. Concatenation is the operation of combining two strings together. Right? Usually what it means is you append one string to the end of another string. Right? So in other words, if in a lot of programming languages, you can do this with a special character. For example, in Java, you can do something like this. Chris plus a space plus Burke, right? And that'll concatenate these three strings together into one big string with Chris space Burke. C does not support this. C does not have an operator, a concatenation operator, i.e. something like the following, right? Instead, you need to use a function to do this. And it's in the string library, str, in the string library, string.h. And you can probably guess as to what this function is called. strcon, I think that is actually a function. It's just not the concatenation function. Instead, they go with the second syllable in this, and you do strcat. Right? So let's go ahead and look up the man pages on that. And there we go. strcat. And it has, like strcpy, it has a destination and a source. So let me go ahead and copy the signature into the notes for you. And it's basically going to take the string and add it to the end of this destination string. So the behavior is that it appends the contents of src to the end of the dest string. Right? It again makes assumptions. It assumes that that src is null terminated, and it assumes that dest is big enough to hold both strings. Right? Again, what it's going to take, say, Chris, concatenate a space, concatenate. You can call this function as many times as you want, as long as the destination string is big enough to hold whatever you're trying to concatenate with it. All right. So let's go ahead and take a look at an example really quick, and that's where we'll end it for the day. And I've created something that's big enough to hold Christopher, Michael, James, Burke. But instead of directly copying it, let's go ahead and use strcat. Right. So before we do that, though, let's undo that, and let's just make sure that you have this example in your notes, because I never copied it over from the exercise. For those that do actually look at the notes, remember they are pushed to GitHub on a daily basis. After every lecture, not only do I update the YouTube, but I also update the GitHub page, or the Git repository. Excuse me. All right, so this is big enough to concatenate. Let's go ahead and get it started by putting in my first name. Because if the original is not properly null terminated, it's probably it goes to the end of the string, and that's when it starts copying things over or concatenating things. So we need to make sure that we start off with a properly null terminated string. The way that I could do that is, of course, I could set it so that it's an empty string by putting the null terminating character at the beginning, Or I could just start off with an strcpy into name Christopher. And to avoid doing so many lines, I'm going to go ahead and put spaces after each one of these. Then I can go ahead and concatenate to name my second name, Michael. And we'll forget that I have two middle names. Actually, no, let's go ahead and do it all. Of course, I don't use James because most forms don't allow two middle names. strcat name, and then my last name, Burke. And there, after that, I won't put a space. And I note here that I didn't put any null terminating characters. strcat will take care of that for you as long as the second one is null terminated, and as long as it fits, it'll take care of the null termination for you. So printf, once again, hello, your name. There we go. And of course, if you're following along, you can use your own name on all of these. Oops. Forgot a semicolon right there. There we go. And you can see that it's been properly concatenated. Concat, concat, concat. And of course, you also have a byte limited version of this. You can use strncat to concatenate at most n bytes, and it works exactly like strncat. You have a source that goes into a destination, and then the last parameter is the maximum number of bytes that you want to concatenate. So, for example, I'll go ahead and copy over Christopher and then Michael, James, Burke. Let's just go ahead and do only the first initial of each one of these. Right? So let's say 1. In other words, I only want to copy over M. And let's go ahead and get rid of this. So my middle of I want to concatenate M, but nothing else. How is this going to work? Let's find out. It's probably going to work, but it is technically undefined behavior the way that this is going to work. So it concatenates just M because I said at most 1 byte, but it didn't necessarily take care of the null terminating character for us. We really need to take care of that ourselves. So I need to make sure that I am doing that by saying name of something, I don't know, is equal to the null terminating character. Okay, well, I don't know where that is, but, oh, I know. I could use strlen, right? strlen of name. And if that's 4 characters, then 0, 1, 2, 3, 4, that's where I want to put my null byte, right? This is bad, right? This is like the chicken and the egg. You're assuming by calling strlen that it is already null terminated in order to null terminate it properly. That doesn't make any sense, right? You are making the assumption that it's already null terminated. Well, if it's null terminated, why are you null terminating it? You can't use something like this. So basically, you have to keep, if you're going to do something like this, you have to keep track of how many characters have I written so far, right? So for example, I know that int n is equal to strlen of name. That's how many bytes, or how many characters are in there to begin with. I copy over 1 more, so let's go ahead and say n++. And now I can use n to null terminate it. And I'm going to add a space here in order to get a space between the M and the Burke right here. All right, so save this, run it, and now that's much safer, right? So again, strncat will limit it to at most n bytes, but it won't necessarily take care of the null terminating character for you if it doesn't see it in that first n bytes, just like strncpy behaved, right? Where is it? If the null terminating character occurs within the first n characters, it takes care of it for you. It copies the null terminating character. If it does not appear within the first n characters, it will not copy the null terminating character for you. You need to take care of it yourself. Okay? All right. No questions online. So that's enough to get you started on your lab tomorrow, certainly. that you can doing basic string copies, manipulating the contents of strings, making sure that they're null terminated. That's all you're going to need. Basically, you're going to complete a game of horse, or maybe it's more appropriately called hangman, where it's a kid's game where you say I'm thinking of a word, and that word has 11 letters, and then you have 11 blank lines, and then you start guessing. Well, R, okay, well there's an R right there, there's an R right there. Q, there are no Qs, so strike one, right? And how many strikes do you get? Strike two, strike three, and then usually you draw the little stick man that's being hanged, and then the game ends if you guess too many wrong characters. You win the game by filling out the entire word. We've got most of the game built for you. You just need to complete 4 string-oriented functions to complete the game and play the game. But that's enough to get you started for tomorrow. What we're going to look at on Wednesday is we're going to look at more advanced string processing on Wednesday. And again, we will be back in Henslick on Wednesday. So taking a look at online one last time. Looks like everything's been resolved. So thank you for hanging out with me today. And again, we'll be back in Henslick on Wednesday. Good luck on your lab tomorrow.